Okay, the last non-parametric that we're going to look at is something called a Kruskall Wallis, and this is used when we want to look at more than two groups. And when you go back and look at the choosing a statistical test paper that you have, when we are doing that with interval or ratio scale data, we use an ANOVA. We don't use multiple t-tests in that situation because if you remember, every time you do a t-test, there's a little bit of error. So if you keep doing that over and over and over, it is going to create a lot of error and you'll make a mistake. So non-parametrics work the same way. If we want to compare more than two groups, we have to use a different test. In this case, it's called a Kruskall Wallis. And we're going to go back to our high school example about the locus of control. And we want to see if there's a difference in the pre-test and post-test scores of locus of control depending on which grade level a kid is in. Then go back to the high school information. And we've got this grades 9, 10, 11, and 12. We've got a pre-test score and a post-test score. So the null hypothesis would be that all those are equal. And we want to see if we can reject that. So we go into this, click Analyze, Non-Parametrics, Legacy Dialogues, K independent samples. That means as many samples as you can get in there. Put our pretest in. We'll reset this grade. We then have to define the grades that we want. Well, we're going to do all of them. So we'll do that. Grade anywhere from between grade 9 and grade 12. Options, if you want descriptors, you can put that in there as well. You hit OK. And you get several tables. You can get the average score on the pretest, which of course that's not exactly right. That's not the best description of that score because you're not supposed to be taking averages of it, but it does anyways. You get the mean ranks for grades 9, 10, 11, and 12. How many ranks are in each one? How many N are in each one? What the mean ranks are. And if you remember from the other times that this is used mean rank data, what it's doing is it's taking these scores and it's putting them in order, and it wants to know if there's a relationship between the order of the scores from lowest to highest, grades 9 and 10, all the way to the top. Does this score have something to do with this grade? And it turns out on this, and we're looking for this asymptotic significance, that it doesn't. The grade level doesn't have anything to do with where these ranks fall out. So in the first question, it asks, does grade make a difference? We see that it doesn't. This is asymptotic significance. It's not powerful enough to run exact significance. This is our test score. Degrees of freedom. And there's a question here that says, what happened to all our kids? Remember, like in ANOVA, it's testing between groups. And there's always one less degree of freedom than the number of groups. This isn't about the kids. It's about testing between grade levels. So that's why our degree of freedom is 3, is because we have 4 different grades we're testing. And the p-value. So is there any significant difference in regard to pre-locus control scores based on grade level? No, there isn't. Statistically, they are the same. Now, let's say, hypothetically, I want to know about the post-test scores also. I'll go back to this, run the same thing again. Move the post-test scores in. Hit OK. Now, you'll notice there is a difference. There, in terms of, there's a difference in their final scores in the post-test locus of control, depending on which grade they are in. So in the post-test, grade level does make a difference. Now, just like in ANOVA, it's not always enough to say yes, there's a difference, because automatically when you say is there a difference, and you say yes, there is, people want to know one more thing. Okay, where is the difference? The problem with non-parametrics is you cannot click a button and make it run the post hoc test like you did in ANOVA. If you remember back to that, it did the Tukey's post hoc test, and I'll tell you where the difference is. This doesn't really work that way. So you have a couple of options. The first option is what I have described here. If you look at the output table, think about how these scores are ranked, the post-test scores, how they're ranked in relation to the grade level that that student is in. The grades 9 and 10, their ranks are pretty close together. Grade 11, yeah, that's kind of a little bit far away. But look at the ranking on grade 12. It really jumps up. That means it's separating itself from these other grade levels. So you have a couple of options. What I usually end up doing is I go back and analyze this, and this is what is found on the sheet that I've sent you out. And I ask it to start processing these one grade level at a time. Is there a difference between grades 9 and 10? This is kind of violating a rule because I told you not to do these like a t-test over and over. And this Mann-Whitney is a non-parametric version of a t-test, not to do it over and over. But we do know there is a difference somewhere. All we're doing now is going and trying to find the difference. So when I do just grade 9 and 10, I find there is no difference. That's not it. So I'm going to redefine my group. Say grades 10, 11. That's not it either, because this significance level is not less than 0.05. Run it again. I'm still looking. Grades 11 and 12. There it is. That's where the difference is between grades 11 and 12. And if there's a difference between those two, more than likely there's a difference between like grade 12 and 9. That's one way to do this. The other way to do it, and I've tried this over and over, and it still seems to work pretty well. It tends to reinforce what I'm seeing here, is to break a rule and run an ANOVA used on ordinal data. And the reason why is because you can run this Tukey's test on that. And the reason I do this sometimes, especially if I have large numbers of data, is it gives you a place to start from. You'll notice if you do this, you do get a difference between the groups. It's not as accurate as the Mann-Whitney. And by running the post hoc, it at least gives you a place from which to start. You can see between grades 12 and 11, there is a difference. Grades 12 is much higher on their scores than the grade 11. Sometimes I'll do that. If I have a large amount of data, I'll do this because it gives me a place to start from, and then I can go back to the non-parametrics and start running the actual correct test for it. It's kind of a illegal way to do it, I guess, without a better way to describe it. But you're still going to go back and run the correct test. It's just helping you find a starting point on that. So I think it's okay to do that. I've never had anybody tell me it's not okay. It's something that I've tried comparing non-parametrics to parametrics at the same time, and I always come up with the same answer by doing that. So I think it's okay to do that. Now, rewrite all that stuff up. This is what it looks like down at the end. So this is included in there. I'm going to send you a practice one, let you have a chance of doing this as well. And that's it.